Hi.
Good morning. So I guess we can start. Just a gentle reminder that the homework 2 is due on Sunday. So I guess most of you have done it already. But as I see from the blackboard, it shouldn't be a problem because it's a generalization of what we have done in the class. So equilibrium. So in this topic actually include two types of model. One is partial equilibrium, where you still focus on one industry where you try to equate the demand and supply, or you just try to solve the problem of the firm and the consumer at the same time. And the general equilibrium we just briefly talked about last time is trying to see when we have the case where they're all the market at the same time, whether we have equilibrium can be achieved in all the markets, all the labor market, input markets, and the goods market. And as you can imagine that the application of general equilibrium now mainly in the real estate market and also the finance assess model, including you want to have equilibrium in the equity market, in the bond market, in the equity market, and the derivative market. So you need all the market clear at the same time. So that is something actually active research, but in economics, more or less, the general equilibrium is more or less stagnant for a while, because basically it's not because it's dying, mainly because it's most of the problem we want to solve have been solved. So there's not too much thing can be done here in terms of economics. But anyway, so let's quickly review what we have done. So I'm not going to in the detail, but I think this slide is sufficient for the purpose of the review. So the partial equilibrium that we learn is there are different types of models, right? There's a perfect competition, there's a monopoly, Carnot, Bertrand, and monopolistic, right? And for perfect competition is exactly this demand and supply framework, right? Probably everybody would have learned it, right, in the principal class, right? And basically this guy, right? And probably is one more thing that we would be talking is here we would go further one more step into the supply, right? Because the demand is basically usually in the classical setting come from preference, and usually we don't say anything more, right? But for supply, we can always go back to say where this supply comes from, right? And then we know it can come from the cost curve, right? Say it's a marginal cost, right? And then the price, if this is the price, right? And there actually means there's some profit here, right? And there will be enter, right? And the long run that then this swing will go out, right? So that is the main thing about the perfect competition, right? It's a very useful framework. We look at things in the grand scheme, right? Look at things in the bigger scale and then industry scale or economy scale. Then this is a relative good model, right? Unless some of the firm actually have a supermarket power, and usually even if some firm have super abnormal profit, then usually attract entry, right? And in that case, their profit is gone, right? Or if you look at the other context, the profit may not be gone if the existing firm can try to use various ways to maintain this profit, right? So one way is to think about is say monopoly, right? Monopoly, if you remember the graph, usual graph is like it's this one, right? The graph is like this. This is the perfect competition. Monopoly is same as you learn from the principal class, right? You have demand, you have marginal revenue, right? The marginal cost, right? And we learned this is actually FOC, right? Maybe I just go there to show, right? So this MR with MC, right here, right? We have the price, right? This is profit, right? So that is, I guess this is what you learn, right? And this is exactly the same same thing here, but we just do more math here, right? But and and the next thing we cover is Carnot, right? And the main idea of Carnot, actually we will cover more, right? Is firms compete in quantity, right? And in these cases, actually you would see firms would have profit, okay, in the short run. The reason is being that they try not to flood the market with a lot of products, right? Say you see the outcome is indeed the price is about the marginal cost, say P is higher than C, okay, and right, P is higher than C. Look at this, the markup is higher than C, and this markup actually cancel out or not cancel out, but vanish as more firms comes in, right? So that is the main thing about quantity competition, okay? And although we just say here, we just take this to infinity, right? And this is just a hypothetical exercise, try to check your model right or wrong, right? Because when you talk about quantity competition or oligopoly model with some firms, say the short run model, right? This is the number of firm actually is fixed, right? Usually this is how we use the model. We are not going to the infinity, but all the time, we just at the beginning of the model, we fix the number of firm, right? The number of firm is not a endogenous choice. I mean, we can talk about those when you talk about free entry and long run, but most of the time, actually, the number of firm is rather fixed, right? And as I following the famous economist Keynes said, right? In the long run, we're all dead, right? The long run is maybe too long for relevance, right? And short run is probably the main thing. The question is why there's no firm enter, right? You look at the case of, say, Microsoft, right? And then they monopolize the Windows system for a very long time, right? And until now, it's still the dominant system for laptop, whatever, right? Or even look at the newcomers. Apple is very good, but I mean, they are only good as an iPad or iPhone, right? So on and so forth, right? Still the commercial usage is still an PC thing, right? I mean, personal maybe still people can use the OS, but that's it, right? And the question would be like, why, right? Or look at oil company. It's almost always those company, right? The Shell, those producers, right? You may ask why is the case, and that is because of entry barrier, right? That is not, you cannot really enter the market, right? Just like look at the schools, right? So you have been Hong Kong U, CHK, so on and so forth, right? And then it's pretty much you cannot freely enter the market. You need in Hong Kong at least, you need to call yourself university, then you need to have get into legislative council where you have to pass law, right? Unlike in the US, where you can simply just go and say you can give degree, then you can give, right? So that is very different. Okay. Or in China, there are a lot of industry control, right? You cannot just simply go there and make a university, right? Now, even you cannot have a tuition center, right? Even if that is not legal, right? So that is a lot of entry barrier in many industries. So that is, they would keep the number of firm not converse to infinity. And there are a lot of literature we don't talk about in this class is why there's a profit there, why don't firm comes in, right? Even though they're barrier, right? And the fact is what we call in the Chicago school, we call the rent anticipation or rent seeking behavior. Is the fact that in order to keep his monopoly status, okay, he's willing to spend all his profit to keep it. Okay, he tried to bribe officials, to try to lobbying. Okay, so that's why although you see profit there, actually it just spent to somewhere else, right? Probably look at the car industry in US, the petrol car industry, and you expect only there are few firms. You should expect they are very profitable, right? And indeed, you look carefully, actually they are not very profitable, right? That's why when Tesla comes out, and they just all Tesla is way more profitable than these other firms. And actually they spend a lot of money to do lobbying, to do things that are not really productive, right? There's a and probably I mean, you look at the history, right? You see the electric cars these days, right? But if you look at the history, actually when the car actually first born, actually at least half of the car electric cars. I mean, that half a car petrol car, half a car electric cars, right? But at the end, you see the past 60 years all become petrol cars, and recently only have electric car these days. And you may ask why, and that is because of they spend money to suppress the development of the electronic cars, right? The electric car comes out and they buy the patent and just suppress it. Okay, so that is some of the reason they keep the profit. I mean, here monopoly, but same as the oligopoly, they just try to spend resources to depress those. So that comes to entry barrier, right? So they would try to make sure that the car is extra safe, add whatever thing they want to add, so that it's expensive to produce cars, right? So they try to make everything they want to make sure that there's no entry. But anyway, and for Bertrand, actually it's a very interesting thing is when they compete in the price, here the result is they end up is like price become marginal cost. Okay, at the end, if they compete in price, if they consider homogeneous good, okay, that is become a marginal cost, so no one make profit. Okay, so actually there are two implications here. First would be firm would try to differentiate themselves, right? Because when they're homogeneous, then they are not able to make any profit. So that's why you see business application for marketing people probably know very well is they try to, even though they're homogeneous, they try to create the impression they're different, right? That's why especially for those goods that actually have virtually no use or have very use practical value, they would have a lot of marketing, right? Marketing people tell us, right? And that's why you see a lot of, off the record, right? Cosmetic, right? Product, and virtually you try to look at the product, actually, they actually do not different that much across brand. We try to look at the details of the chemical, right? But why is one cosmetic brand cost so much bigger than other, right? And because of the more extensive brand would have a more beautiful or more handsome guy to do advertising, right? I mean, obviously, even you put up that cosmetic, you don't become that beautiful woman or handsome guy. You will never become true, but you got the impression that it's there, right? Actually, you create a heterogeneous good because you have some consumption together with the image, right? Having that thing make you happier, right? Just like as you can imagine, same as the cigarette, right? The cigarette actually, cigarette A from cigarette B usually don't have much difference, right? Although there might be some difference, but why the one cigarette ban you charge you more than that, right? Because of you would say now you don't allow, but in old days you when you are before you guys are born, cigarette advertising is everywhere, and usually, I mean, US hopefully you have a cigarette smoke and then a very cool cowboy and bum and then save a beautiful woman, right? Then once you smoke that, you will feel that, oh yeah, I'm the cool guy who shoot the bad guy and then save the beauty, right? Save the world, something like that, right? So that is a creative impression, right? I mean, you consume that, you also enjoy the sense of whatever psychology gain, right? You become heterogeneous, right? So that is the story. I mean, probably marketing people can also tell us another story, right? There's another thing is like two cigarette brand, right? A and B, right? And A is very attractive, and B try to win, and the story is say, okay, B try to do the advertising method is try to say it give the ban A cigarette to those people who are going to death penalty, okay, and give it for free for those people, and then they try to name the brand A, saying this is a cigarette. Once you get it, then you die. This is a cigarette for the death penalty prisoner. Okay, so you associate brand name with that, right? So it also a heterogeneous, make it heterogeneous, right? So that is the first implication. That's the explanation why firms want to differentiate, right? Actually, later we talk about hoteling model. Actually, that is, I mean, probably most of you would know, right? The hoteling model is the main idea why firms want to differentiate, right? When we go to the same place, right, we have a Bertrand, and if they separate, they will have non-homogeneous, right? It's heterogeneous, right? It's more or less similar to when heterogeneous is similar to like this monopolistic. Okay, hoteling model is the way it's similar to this one. Okay, but hoteling model is give you a location. Okay, and this one have no location, but the same idea. You can actually, you can make a hoteling model in the same favor, actually the same thing, because hoteling model or whatever, this model saying that you are facing a downward sloping demand, right? But also you're just not facing the demand on yourself. It also depends on other firms' price, right? So this is, if you take it as a hoteling model. We talk about the model when we talk about game theory, but that would be the same idea here. You're facing a downward sloping demand. If you look in the same location, heterogeneous good, right? So this is the same, okay? And in that case, you can see there's a profit in the short run, right? If there's no fee entry, then actually you enjoy some profit, okay? So that actually also explain why we have the product differentiation, right? Because when you have no differentiation, you have a Bertrand. When you try to differentiate, you have some profit, right? At least in the short run. I mean, of course, if the market is competitive, then you can't. But as we know, firm invest a lot to try to differentiate from each other, right? In that case, every firm will enjoy some profit, okay? And they try to also make barrier of entry, right? So that's why it's very difficult to compete, all right? So that is if you are a new entrant, okay? I hope it's clear what we're doing, and indeed, actually, this model cover most of things, although this monopolistic is like kind of abstract, but if you try to build in more details, actually include almost all the thing you want to do, right? Depends on how you, basically all the model, right? In the IO, you can say it's this model, this format, okay? But the thing is, like, the difference is whether how you define this Q, right? Usually in the IO model, or I don't know marketing enough, but at least for my research area, the Q is like they would differ depends on how the market looks like, right? And of course, here I choose price, but in the general model, maybe you can have other things as well, like hoteling, you choose location, right? You choose quality, so on and so forth. But in general, this is the model that actually you'll be using. I mean, there's a variation of different types, right? For example, you have network, the network effect, right? Or you have advertising, you have another dimension to that, okay? But the idea is same, okay? They're same. So, is there any question before we proceed? Because I guess this will be okay. And of course, some of you are actually doing operation management, right? And actually, then you will see this will be similar, right? But operation management will have a big thing on this guy, the C. Okay, how do you manage the supply chain? Get to here, and also here we only have one layer of firm, right? You can consider there's a vertical layer, right? There's upstream market, okay, and then upstream market they compete and then sell to downstream market, so on and so forth. So, but you can just say these are taking only one layer by layer, right? So that should not be an issue. Okay, just solve equilibrium at the same time. And actually, go back to the general equilibrium idea, right? Because you need to make sure that all the market was solved at the same time. Okay, but that is not difficult to imagine. You have one wholesaler, multiple retailers, so on and so forth. Okay, but that is beyond the scope of our class. But when you do game theory, actually the tools apply to everything. So that is basically once you learn game theory, actually you would know how to handle everything with the same tools. Okay. So I guess I quickly go to the general equilibrium. I hope I can finish this set of slides today, and then we talk some uncertainty today, because I guess we are pretty much behind the schedule. But there's too many things. I mean, I don't know what to cut. For general equilibrium on the cut, but if I cut, then the people in the finance may not be very happy. Although I cover something here, but at least it will be useful for some purpose. Okay. So just very quickly, the notation. I guess after a week, then probably we need to familiarize yourself with the notation. So I think I follow the notation in the textbook, Randy textbook. So Jahir Randy. So that is you have I consumers and there are K goods. Okay. So consumer I K good. Consumer will be described by the superscript, and the good K is the will be the subscript. Okay. And that means that consumption bundle is a vector. Okay. Of K good, N good. Okay. And then you assume the preference already, and then there's endowment for N goods, and an exchange economy will be just the primitive of this model. The information, the input, or the primitive or the input of this model, it just give me the preference and give me the endowment. Okay. The question is, this is the input of this model, and the output of the model, or the solution of the model, is what we call the allocation. Okay. And then we achieve, given the setup is what we have, endowment is what we have at the beginning. Okay. In this model, we call exchange economy, is because there's no production. Okay. You just imagine that, I mean, you inherited from your parents, you have 3 oranges, 5 apples, 6 banana. Okay. And then the question is, you are not happy with what you have. Okay. You want to exchange. The idea is like, if everyone has already had a satiation point, then you don't have this model, right? Yes.
X is what consumers have in the end, or what they have added to
at the end. So X. Okay, this is the allocation to the consumer. It's like after some black box, this is what they get at the end. So basically, it's just like endowment would be, say, guy number 1 we have 3 apple, 4 orange, 5 banana from his parents. maybe just fall from the sky, or maybe this you are going to the island, the tree go there. You own the tree, then you have this thing. And everyone will have some starting point. And then allocation actually means that, I don't know, maybe there's some dictator, okay? Say, okay, all of us have this much, say we have 10 orange, 10 banana, 20 apple. And I said, okay, you got 1 apple, 3 bananas and 1 orange. And he get how much? And allocation is saying each agent what they should have at the end. Okay, it doesn't matter. We didn't say about how we get there, but it just say who get what.
So the X means what they usually get during the process, but not what
they will consume. So I just say in the beginning we have this much of apple, banana. Each one have some ownership. This will represent ownership. Okay, the EI is the ownership. Okay, and here is at the end after the redistribution. We don't know we don't talk about mechanism yet, but just like he will at the end he'll eat that apple.
But if an economy is an exchange economy, can these consumers just give some of their products in order to exchange for some other product?
Yeah, that's what the exchange economy, just like they exchange the thing. And yes.
So any X could be negative.
So exchange economy, that means that there's no destruction of the material and then no new material comes out. It just, you can imagine there's no technology that can transform 1 apple to an apple juice. Okay, if you start with apple juice, you cannot make apple. You can make apple juice from apple. That's it.
So I mean, in this case, X could be negative.
No, it's all the positive, all positive number.
If I give something in order to exchange for some.
No, it's still positive for you. It's allocation. It's like I dictate how much you are consuming. So you're consuming X. So you just, E is what you have at the beginning. X is what you're at the end. That's it.
So X should be greater than E.
Yeah, that is that. No, not, because you can change. Because E is not what we have together. Okay, we together have some of the E's, right? Some of the other, which is actually this guy, right? So we can define this is some of the resources we have. Okay, or put in this way, you can imagine exchange economy is we have total resources. Okay, and E is telling us who get the property rights on those. Is a well defined. Say suppose together we have 10 apples and 10 oranges, and say according to some custom or tradition, you have what? You own 1 apple tree, so you have 2 apples, and you own 3 apple trees, so you have 6 apples. Okay, so on and so forth. And allocation simply means I don't know what. Maybe the God, maybe the dictator, maybe we somewhat agree. You, regardless of what you have, anyway, you have 2 apples to eat. Okay, that is what you have. You can throw away, that's fine. It's your issue, but you have 2 apples. So it's X.
Why the explanation could be different? If the whole process is just an angular allocation, so I think the combination of X should be equal to the combination of T.
Oh yeah, that is what we mean by the feasible allocation. So the question is like, okay, what is the restriction on X, right? So X is like exchange economy. That means that you don't produce. So that's why exchange. What exchange means that you are not, as I said, you say suppose a good have apple juice, then you cannot produce apple juice from apple. That's what it means. Because if we consider we can transform apple to apple juice, then the model become more complicated. So, but you can look at the textbook. We don't cover that part, but it will be the same. Everything we talk actually can go if we assume firms are competing competitively, so assume perfect competition, okay? Because in that case, the profit would not be mattered because there's zero profit, okay? But if you have, say, imperfect competition, in that case, firm are making profit, okay? And profit must be go to somewhere because firm are just machine, right? So then the allocation of the profit will be an issue over there. So, but I mean, we don't talk about those questions. And there are many questions you can talk, but the exchange economy just like you don't produce new good. So we just have something there. We have some ownership at the beginning. At the end, we exchange the ownership and then we consume. Okay, just trading ownership. That is only what we are doing. Okay, we are not doing anything. Okay, other than just I give you one apple, you give me 3 banana. That's it. Okay, and that's our exchange. Okay, and we're talking about what is the way to exchange, right? And in this particular model, we're talking about using price to regulate the exchange. Okay, you can imagine in this model, just like you talk to your neighbor and then just exchange, right? And not everyone trade with everyone, right? But here we have a model with price, okay, and we have competitive price such that everyone is look at this price can do trades, okay. And in that case, there will be a good equilibrium comes out, okay. And those people who learn from finance will actually know this is actually the stock market, right? Everyone can buy and sell there, right? It's different from OTC market, right? Over the counter market where just people just talk to each other without letting the public know. But it's just saying why the stock exchange is good in some sense, right? If you in that sense. Okay, go back to your question. What the restriction is like you cannot allocate more than what we have at the beginning, right? Because you're just exchanging, you're not producing new thing, you are just exchanging some ownership. Okay. In the beginning ownership, and then at the end we trade some ownership. Okay. And you do see that in this model, there's a lot of simplification, right? There's no transportation cost, right? Everyone can trade with everyone. Everyone know what's going on. Of course, that is a limitation of this model. But this is the feasible allocation, which is we denote as spec F. Okay. And of course, it depends on what we have, right? So usually, I mean, it's good to talk about this because you also learn that in the I think it's good to look at the Edgeworth box, okay? Because this is what usually people would do, okay? It's in the two-person, consider we have two agents. Say I is equal to, okay? And N is equal to 2, okay? Two agent, two good, okay? Maybe when say suppose there's a guy, okay, and there's a woman, there's a boy, a girl, right? And say we have two good, right? So maybe he has 2 apples, okay, 1 banana, okay, and the girl have 3 apples, okay, and 2 banana, okay, and these are all endowment, right? So the question would be like, okay, how do we represent this, right? How to represent the feasible allocation, right? So the easiest thing is look at the Edgeworth box, okay? And it's a 2-dimensional box, okay? And then usually you put a guy here, you put a woman here, okay? Doesn't matter where you look at, but the guy will look at in this dimension. Let's say suppose this apple dimension. This is banana dimension. Okay. In total, how many apples we have is we have 5 apples, right? So assuming perfectly divisible the apple, just make the things easier. So you have 0 apple 1, 2, 3, 4, 5. Okay. So this is 5 apples. Then we have 3 banana 1, 2, 3. Right. So how can we represent the initial endowment in this Edgeworth box, right? The guy have 1 apple and 2 banana, 2 apple and 1 banana. So this guy, this point, right? This is the point. And actually, this also look at the girls perspective, which is also is like 1, 0, 1, 2, 3, 4, 5. So here from a girl perspective, there's a free apple, right? So 0, 1, 2, 3, 4, 5. Okay, this point from an apple perspective, and the banana here is 2 bananas. So this point is actually representing the exact endowment. Okay, and you would ask, what is the big F? Is actually any point in this rectangle. Is that clear what we are doing? Okay, the endowment is any point on this rectangle. Okay, and what's this rectangle is actually the horizontal is the apple, it's just like total apple, right? And this total number of banana. Okay, so this F is everything inside. Okay, if you go outside, it's not possible in this framework because it's exchange economy. Okay, and yes.
Actually, you're seeing the constraint is simply an equation, but in your formula,
oh, you can allow some ways. Yeah, you can allow some ways. You can allow something. Yeah, you can allow something some ways. Yeah.
That means there are something that is not allocated to
oh, basically you can imagine this is the point, okay, to him and to her, and then you can look at this diagram. You can go down a little bit and go up a little bit. This for him, you can go down a little bit, then you waste. It's fine. Still represented by this graph. So you see what I'm saying? So basically, is you pick up a point here. Okay, the girl get this much. Okay, you can basically reduce the guy. We can reduce the guy without moving the girl, or you can move a little bit, reduce the girl again, because this is a look at from the perspective of this one. So you can also represent by this graph. That's fine. Okay. So this is the graph. So the utility, as assume we consider the continuous strong increase in the cosine concave. Is the more the better. Okay. And in this model, we assume price taker. Okay. So because of we just learned how to do consumer problem as a price taker, right? So that is natural assumption. Okay. And we actually learn if the price are positive, there will be a unique solution. The reason is being if price are 0, then a lot of things can happen, right? For some good, the price is 0, then you have maybe have some issue. But we learned that and under the certainly cosine concave, then you don't have problem. The why you have the price of them is non-zero, because when you're non-zero, then you have a downward sloping budget set, right? You have consider the 2 good case, right? You have x1, y1, x1, x2. Then when you're positive, then you have some slope. If you're 0, then you end up in here or end up in this guy. Okay, so then things become more complicated. So we have we approve it, right? We know this is actually this is somewhat this is exactly the Marshallian demand, right? The only difference is this only also depend on P, right? But he's a price taker. Okay, so that's why the value of his endowment is fixed, right? It's not his choice. He's not choosing the P. He's only choosing the consumption vector bundle. So that's why it's a Marshallian demand, right? And the next thing we learn is what we call excess demand. Excess demand is just you can imagine the Marshallian demand minus the endowment. Okay, and what we are trying to do is try to say, okay, the following. Okay, if under this excess demand we try to show this is continuous, satisfy homogeneity, satisfy Laplace law. Okay, and actually these 3 things we'll use in the proof. The first one is continuous. I think that is not very surprising result, because the Marshallian demand is continuous, okay? And when the utility is continuous, so that's not a big deal, okay? Actually coming from, because the maximum of a continuous function, actually the solution also continuous, okay? That is actually coming from what we call the Birch maximum theory. It's a math result. I don't think we need to worry about that. Actually, we have been using without any concern. The second one, I think, is also trivial, right? Just like if you double the two, then the same, right? Because that's what we learned, the homogeneous degree zero of price and income, right? So that is the same thing, okay? Because you double your price, actually, your income and your prices facing also double. That means that you have the same choices, okay? So the Marshallian demands are the same. The last one is the most interesting one, is the value of excess demand is zero. Okay, so that means that that later we prove. Okay, the main thing is the Z's are non-positive. Okay, the Zi, actually what we prove is that using the fixed point theorem, we try to prove this guy would happen. Okay, this will prove this one. Okay, and then we are saying that this guy, okay, suppose this guy is positive, okay, not negative, okay, and in that case, right, if the dot product, the multiply, is equal to 0, what does that mean? Okay, it means that when Z is negative, the price must be 0. Okay, because price are non-negative, right? So you multiply something equal to 0, it must be the case when this is negative, then it must be 0. Okay, that means that when the excess demand really exists, it should what value? When there is a no excess, so there's a C is less than 0, right? Means that you have more endowment than people demand, right? It must price at 0. So what is free good? Free good, it means that when we have free good, okay, we have excess supply to those. Just like air. Why is free? Because in the earth we have more air than we need, right? So that is why those things are free. Okay, and when we have free lunch or free thing, it's because of we have more resources than everyone we want at the given price. So in that case, it's free. Okay, so but anyway, let's try to prove that guy. Okay, and the Raoult's law actually coming from nothing but just the summation idea, and also so basically just coming from the summation process and budget constraint. It basically just coming from budget constraint, right? Because budget constraint implies everyone, the value, the budget, the total value of the budget is exhaust. The value is exhaust, so sum of everyone. So the excess demand also exhausts. So that is the main idea. Okay, let me repeat this. Why this whole? It's because under your preference is increasing, right? That means that you exhaust your budget. When you exhaust your budget, you sum of all the budget actually give you the value of the excess demand. Okay. And that is what it means, the Raoult's law. Okay. So we try to prove there's a price vector such that this is less than or equal to 0. Okay. In general, you can actually, if you put a stronger assumption, you can actually prove this is 0. Actually, you can prove this is 0. If you look at textbook, they put a stronger assumption there, but I just put a less weaker assumption. Okay. So if you assume continuous strong monotone, whatever, and down positive, then you get a price where people don't want more than we have. right? Z is the total. Remember, the Z is the sum of the Maxwellian demand minus the endowment, right? So negative means that you don't, at this price, you don't want more than we have, okay? So that will be equilibrium. Why? Because Z is coming from everyone is maximizing the utility at that price, right? And everyone at that price is happy. No, they don't want more than what they want, right? So it's equilibrium, right? So we try to prove this result, okay? So the way we prove, we don't go line by line, but I just give you the rough idea because this is standard way, usually how people prove existence of equilibrium. When we talk about equilibrium, usually it's fixed point idea, okay? I just give you the idea because unless you're doing the proof, it doesn't really matter, okay? But it's good to know what's going on, the logic, okay? The idea is very simple. The first case is you normalize the sum of the price to be 1. That's a standard step. And why you do that? Why you can do it? Because it's what we have homogeneous, okay, in price. The second property, just remind you why we can do the first line. It's because we have this result, okay? You can always make, because multiply the same, so you can always normalize by to 1, right? Because you subtract the sum of the prices, right? You give me any p, okay? You give me any p, okay? I consider lambda will be sum of the p, okay? And you divide, then it must be 1, right? Is that clear? Or maybe I could put this one, maybe more easy to see. 1 over sum of the p's. Then you multiply by the original p, then it must be 1. Is that clear? So that's why we can normalize this to 1, sum of the price, okay? So what is the good thing about here? Because when you simplify this n-dimensional, n numbers, okay, you can always, what we said is a terminology in math, or we often use in proof, is called the simplex, okay? You can put it in the triangle, right? Just like if you talk about, right, that's a good one. So now we have P1 and P2, okay? Suppose the 2 price in 2 dimensions, the simplex is actually means this triangle. This is 1, this is 0, this is 1, this is the simplex. This is this is the 1 simple, I think 2 simplex. The 2, yeah, 2 simplex, okay? And why is so once you know the simplex, actually you will see this is a mapping from the simplex to real number, because this is a real number. Okay. Oh, I think I have a typo here is n-1, so this is should be n-1. -1 here. Sorry, typo here. And so here looks like now what we're going to do is we need to this is the step where it's a magic step, okay? This step is come from nowhere, okay? And how you come from this is coming from where is trial and error, okay? And just like, I mean, I don't know whether you learned the solving a differential equation, right? If you ever try to solve a differential equation, someone tells you, okay, this is the solution, and you verify and you're done, right? You ask, okay, how you come up with magic step? Okay, so trial and error. Okay, so here a trial and error step, okay, which is coming from nowhere. Okay, I mean, if you're genius, then you can see directly. Okay, but as long as we're not genius, then someone comes up this. Okay, so but this one actually is a very have a good intuition to that. What we're doing here is, okay, we're given a we're trying to construct a function. Actually, it's a we call a price adjustment function. Okay, so if we start with the price, actually it's equilibrium, then we're done, right? But if not, then we try to find out the way to adjust. Okay, so this is the adjustment function, you can say. Okay, what it's doing is, suppose you give me the price. Okay, the g function is a price. So what I'm going to adjust. Okay, the adjustment is like this fraction. Okay, this fraction is 1 plus sum of this and over this, and numerator is this guy. Okay. Without doing anything, you will know the denominator is bigger than the numerator, right? Because everything is positive, right? The price is no more than 1. Okay. So this guy is a fraction. Okay. This must be between 0 to 1. And all the price are positive, right? And okay, you may complain, okay, Z can be negative, but now we have max. So this guy is at most 0, right? 0, right? So that's why it cannot be negative. So that means it is always a fraction. And Z, this is continuous function. The reason is it's a number and it's continuous. And using the max function is also continuous, so everything is continuous. Okay. And the next step is trying to show some of these are actually 1. Sum of all G, okay, from 1 up to N is actually 1. Because the sum of them, actually sum of all P is this. All the denominator, look, the denominator is independent of the K. Okay. So you sum of all this, just sum the numerator, right? Some numerator, actually sum of this is this guy. Sum of all P just 1. So this is a number in the simplex. Okay. So that's why it's the adjustment. You give me the price, actually they give you another price. You can imagine that. Okay. And why this new price is better than old price? Okay. Why is adjustment? Okay. The reason is, okay, if there's excess demand, okay, that means that Z is positive because Z is Marshallian demand minus the endowment, right? There's excess demand. That means that what will happen is this is positive number, right? And in that case, okay, this is bigger than the P, okay, right? And that is, this will be bigger than, in some sense, bigger than the original price. Okay. And if you have, if everything is like you have suppose excess demand, okay, it should be negative, right? But it is blocked by some 0, right? So that's why it's all 0, right? Then you just go back to not original, right? Because this is independent, right? Only you look at this guy, right? Because the same for everything, every single thing, right? So look at the price, okay? So that's why when we have equilibrium, okay, the Z must be less than or equal to 0, okay? So that means that when we have equilibrium, when we put in a P, then you got a P, right? When you're not equilibrium, you're likely to see that when P goes in, then the price would adjust accordingly, right? You will adjust excess demand, actually, the price will adjust upward. Okay. So, and how do we prove there exists such a price? Okay. Actually, we would rely on, last time we said the fixed point theorem. We don't prove it. Okay. And if you look at the textbook, actually there are many versions of fixed point theorem. Okay. And that is not easy. I mean, that is a result that is not actually very well known in the early days. Okay. That's why if you learn the story of John Nash, okay, who tried to prove the existence of Nash equilibrium, which is also apply fixed point theorem. Actually, he spent I think several months to actually try to actually prove without using fixed point theorem. Okay. And he talked to Neumann, which is the guy who would start the game theory, right? And he said, okay, what you prove is just a fixed point theorem. Okay. And actually his proof end up in Economic, I think just 2 pages. I think it's one of the most cited paper in economics. But now I don't think anyone cite it. I mean, if everyone who uses this concept will cite it, then it will be crazily large. But this fixed point theorem is something not very well used before, besides proving some in economics. Okay. Okay. But this is the existence of a price that would equal the two. Okay. So why are we doing this? Is because next what we will do is, because exists price, we'll manipulate this equation. Okay. How do we manipulate? Okay, is to multiply the denominator to both sides. Okay. So we'll try to show this price is actually a Lavoisier equilibrium price, which is the excess demand is non-positive. Okay. So you multiply the both sides. Why you do that? When you do this, is 1 plus P times this guy, but both sides of this guy. So that's why you have this times this and this guy. Is that clear? This 1 times this guy cancel out. So this 1 times this. Okay. That's how you get the first line. Okay. And the second line is what you do is just you multiply both sides by this. Because we have k equation, each equation you multiply zk. It should be bold there. This should be bold there. Sorry, this should be bold because of vector. This two should be bold. Okay. And still we have n equation. Okay. So the key here is what to proceed is you have k equation, you add all the k equations. Okay. And why do we want to do that? Because of the Lavoisier's law. This is 0. This is 0. So that means that only this guy is left. Okay, so that comes to the next page. Why is this is 0? So that's why only the right-hand side is 0. Okay. And you can see from this expression, okay, it's maximum of this or this, right? So it is either 0 or you have square, right? Because either you have 0, you pick the 0, either you pick a 0, you either pick the zk, right? You pick 0, then it's 0. You pick zk is square, right? And okay, and you have either sum of these things is 0, okay? Then it must be either they are, it must be 0, right? Or they're negative. They cannot be positive, right? Suppose one of them positive, then end up this thing bigger than 0, right? So that's why it must be. That's how you prove it, right? It's by contradiction. Okay. So that means that it's negative. That means that this is exist a price that can equalize. It will make the excess demand non-positive. Okay. This is how we prove it. And this proof looks like not very useful. Very unique, but as I told you, if you try to prove any equilibrium, whatever equilibrium, you use this. You have equilibrium that try to map to itself is the standard proof. Say this is the proof. Actually, you prove the existence of Nash equilibrium. You just modify a bit, then you can prove that. Okay. And here we adapt it to the argument, and unless you do theory, I don't think you would face again. But just the idea, try to tell you how you prove equilibrium is right. It's just like you try to construct some adjustment like function and try to see if the fixed point theorem apply. Okay, and try to again go back to see if you can make that happen, right? Because at the end of the day, we want to prove is the set p less than 0, right? So the way we do is try to figure a p such that some adjustment process at the end will lead to what we want to have. Okay, and this construction is genius, right? You can't really, not very natural. Okay, but you can imagine that they spend months or years to prove it. Okay, so just see it for 5 minutes, probably is like unnatural, right? But this is one way it works, so this will work, right? Because this is not a construction proof, right? It's an existence proof. It's rely on fixed point theorem. Okay, and of course, so if you learn mathematics, some people hate this kind of construction, right? They really like the construction actually tells you how to construct, right? But this one is like, okay, I construct something that exists. Okay, that's it. Okay, so it's not a good. Sometimes it's not the best construction you can have, but that's what we have. Okay. Yes. Sorry.
What is the name of?
Oh, it's existence of general equilibrium, existence of equilibrium in general equilibrium. That's a famous. This existence of Lavoisian equilibrium.
I want to refer to some papers.
Yeah, there's existence of Lavoisian equilibrium. Actually, as well said, that's exactly what I said here. Existence of Lavoisian equilibrium or Lavoisian equilibrium price. So this is exactly the proof. And then you can look at the proof. I mean, there are. Oh, if you try to prove, as I said, there are many versions of this model, and you can have no less than hundreds of different proof under different settings. And different proof will rely on different fixed point theorem. And recent development is like they can do away with fixed point theorem, but they do manifold, which is more complicated even. But fixed point theorem is one of the earliest techniques they have been using. Okay, and okay, I'm gonna end this slide with a break. So here we have proof actually, right? They exist a price, okay, and feasible vector. This solve this problem because this is in the Lavoisian equilibrium. Actually, we have less than this, right? And suppose we focus on the case where all the price are positive, which I think is a natural thing you exist, right? Then this would hold for every single price, right? Because we multiply must be 0, right? So it must be the case. This is 0 because the Lavoisian law is like this, right? P dot z is 0, right? So if every single price is positive, how we end up in 0 must be every excess demand is 0, right? So then you have a price, okay, and set up Babel's constant and this, and such that this solved, okay. And actually, it looks technical, but it do have a important result saying that okay, there's a price that all the market can be in equilibrium simultaneously, okay. Although it looks trivial to you, actually in the days of 1910 to 1930, actually economists are searching to try to see if they actually exist. Actually there's such a price. Of course, now it's not a concern, but in the old days, actually they worry about the existence of the price, especially during the days when they have World War I and World War II, where people see the value of capitalist system, right, end up in the war, right? If the price is so good, why we end up in war, right? Because war is destroying resources, as far as we know, right? And why we end up with this? Of course, one explanation is possibly is because this kind of model assume you have a well-defined property right. Right? We have at the beginning, we know the boy have 2 apples and 1 banana, and the woman have 3 apples and 2 bananas. Okay? In this model, we don't allow the woman hit the boy and get the apple and the banana. Right? If he can do it, then there's no market. Just basically slap him and let's grab everything, right? But that's not. I mean, we don't allow in this model, okay? But of course, oh no, not laughing, but that is actually what is development in economics. In the 70s and 80s, they start to talk about when we don't have property right, what happened? But actually, there's one of course and those kind of along that line to talk about the well-defined property right is very important in this kind of model. Yeah, that is a very important concept, right? With the property right, that everything doesn't work very well, right? That actually explains why in China why the high tech is not working is because the property right is not very well defined. No one want to do R&D, right? You do R&D, someone will steal it. I mean, there's no protection. It's very hard to protect. Okay, and even the court has say someone infringe your property right, and then it's hard to exercise because someone just say I declare bankruptcy. Someone is not. I mean, it's not. There's some issue there. But anyway, I mean, it's not today's talk, but they explain why this has become a very important part in microeconomics, because people worry about whether actually the price can solve the problem. Right? It's the important thing is like there's only one single price. Everyone will know the price and they trade, then there will be no problem. At the end, everybody will be happy. At least given the price, everybody is happy, right? People doing maximize utility, right? Given the price, no one is unhappy. Okay. And actually, we will prove after the break. Actually, this is the main result. As we said, it's first welfare theorem, which is saying that the market outcome is actually Pareto efficient. Okay. And what is Pareto efficient? Pareto efficient is the minimum, you will say the minimum efficiency requirement. Okay. Minimum is the weakest is in the sense that if I said this is the initial allocation, okay, and I propose another one, okay, suppose this is the market outcome, Laplace equilibrium, okay, and we say it's Pareto efficient, it means that you cannot make everyone better off, or you cannot make someone better off without making someone worse off. Okay, so let me repeat the statement because it's very important. Pareto efficiency means you cannot improve everyone. Okay, or when you improve someone must be worse off. I mean, the same thing. Okay, so the idea is that we call allocation the Pareto efficient. If there's no other allocation that is feasible, such that everyone is weakly better and someone is slightly better. Okay, so that means that you cannot make someone slightly better without making someone worse off. Okay, so the first welfare theorem, probably you will recall from your principal class or intermediate class, is Laplace equilibrium is Pareto efficient. Okay, so the market actually leads to outcome that unless you want to make someone worse off, you cannot make someone better off. Okay, so that is the idea. So let me stop here. We will try to talk about the rest of the break.